National Technical University. So let's talk about modeling of 6061 aluminum alloy deformation diagrams by machine learning method. So improving the reliability of responsible structural elements and avoiding industrial accidents is an actual task. Therefore, the prediction of stress-strain diagrams is of high importance. So we know that in general methods of experimental studies are often complicated and expensive. In particular, with a large amount of experimental data, they need to be generalized, that is to find the dependence that the most accurately to approximate them. So if we have in the presence of experimental data, it is advisable to use machine learning methods in order to predict stress-strain diagrams. So the aim is a study to predict the deformation diagrams of 1661 aluminum alloy by machine learning methods, in particular neural networks, boosted trees at temperatures equal 343 degrees Celsius and 413 degrees Celsius. So many scientists apply various methods of machine learning to solve some fracture fracture mechanics, in particular to predict the fatigue recron rate. So the deformation diagram of 6061 aluminum alloy should be predicted by the algorithm of supervised learning, that is neural networks and boosted trees. So what is a neural network? Neural network is a modern method of machine learning that we use in the field of fracture mechanics. And neural networks is one of the machine learning algorithms where the computer can learn to solve different problems by analyzing examples of training data. And in addition, neural networks are the family of models of organization of biological neural networks. So here you can see the biological neural networks. So our brain, for example, consists of 100 billion of neurons. Neurons constantly gather information and perceive it through entire brain. For example, neurons communicate with another neurons through axons and synapses. So here you can see the comparison for biological neural network and artificial neurons. So let's start to talk about artificial neural model. So neural network is, for example, a system that consists of simply neurons. For example, if we have our inputs x1, x2, and so on, and they arrive to our neuron. After that, the signals is multiplied by our weights W1, W2, and so on, and fed to the adder. Adder adds the weighted inputs, and we obtain the new signals net. After that, the activation function is someone process with these signals, and our neurons can perceive the output signals out. So, in order to build neural networks, we should choose which models we can use for our network. In general, we have three classes of neural networks. First classes is single layer feed-forward networks. It consists from input layer and output layer. For example, multi-layer feed-forward networks have at least one hidden layer. And recurrent neuron networks, it have at least one feedback. There are three ways for neural network learning: supervised, unsupervised, and mixed. In this case, we use, for example, as knowledge couples, input-output couples. So another method of machine learning is boosted trees. The main idea of this method is to reflect the natural thinking process when person make a decision. Here you can see example of data set and the corresponding decision tree of this data. So let's talk about deformation diagram. So deformation diagram of the aluminum 6061 alloy is predicted by machine learning methods according to the experimental data obtained in this paper. So stress and temperature are selected as input parameters, where deformation is the output parameter. The input and output parameters were normalized using decimal logarithm function. Without, for example, normalization, our error can increase. So it's better when we use normalization for our database. So during the learning, we, for example, we use two parts of our database. First, this is the training data, and another, this is the test data. We divide our database into two unequal parts. So here you can see the predicted and experimental data of the strain for these temperatures obtained by the methods of neural networks and boosted trees. It should be noted that here points in these figures is quite close to the bisector of the first coordinate angle that confirms that our experimental and predicted data are in good agreement. So here you can see the predicted and experimental dependence of the strain on the stress at different temperatures obtained by the method of neural networks and boosted trees. So in this slide you can see that our error of training data and test data is stabilized in the when constructed 1,459 trees. Here you can see the parameters of neural networks and boosted trees. For example, the name of networks we used multi-layer perceptrons. This is here you can see 2, 9, and 1. It means that we have two neurons in the input layer, 9 in the hidden layer, and 1 in the output layer. So in the study, the loss function was chosen as the mean square error, and the error of the neural networks equal like this, and the error of the boosted trees method in 0.3%. In general, method selection and database is important things in order to obtain the great result for the prediction. Generally, it will be better when we use supervised learning methods for our prediction. And it was found that the prediction results are in good agreement with the experimental ones. Thank you for your attention.
Other questions? Comments?
Can you interpolate somehow neuralize, I don't know what to say, between both temperature. But that would be interesting. If you have, I don't know, 350 or 350, no, 400. Yeah, there's something in between. Let's say 380.
So here you can see predicted data for temperatures 343, and here you can see predicted data for temperatures 413.
But what can you do if you want to have the data for another temperature?
So we can predict, for example, if we use a neural network and build some networks, yes, we, for example, divide our database into unequal parts, training and test. Our network is study for training data. After that, we can prediction test data. So we can prediction new data that our system has not seen, for example. So if we use another temperature, our network will be predict this data.
Questions? Okay, then thanks again.